This video is for lesson 40-1, applying the addition rule. Learning goals are to learn the addition rule and use it to calculate probabilities. So addition rule here refers to finding the probability of an event happening by adding some probabilities together. Let's work our way into this topic using a Venn diagram as we practiced in a previous lesson. There are 100 houses on the street. Some houses have attics and some do not have attics. Some houses have basements and some do not. In the diagram, the circle labeled A are the houses that have attics and the circle labeled B are the houses that have basements. Notice there's some overlapping, which represents the houses that have an attic and a basement. Notice the number in the corner. These are the houses that have neither an attic or a basement. With these counts, we can find probabilities. For example, we could find the probability that a house has an attic, which is P of A, by adding up the numbers in the circle, 29 plus 23, which is 52, and dividing by the total number of houses, 100. The probability that a house has an attic is 52 out of 100. Or we could find the probability that a house has a basement by adding up the numbers in the basement circle. 23 plus 34 is 57 out of 100. We could find the probability that a house has an attic and a basement. Notice the symbol I'm using to be the word and. That is the overlapping area, 23 out of 100. Finally, we could find the probability that a house on this street has an attic or it has a basement. Notice the symbol I'm using to be the word or. In this case, it's everything in the circles. So 29 plus 23 plus 34. That makes 86 out of 100. Now this lesson here is about the addition rule. And what the addition rule is about is a quick way to find the probability of a union of events. A or B. The addition rule says if you want to find the probability of A or B happening, you could take the probability of A, add the probability of B, but then subtract the probability of A and B. This is the addition rule, and it's used to figure out the probability of A union B. We can check that this works using our probabilities that we figured out on the left side of the screen. The probability of A was 52 out of 100. The probability of B was 57 out of 100. Minus the probability of A and B was 23 out of 100. 52 plus 57 is 109, and 109 subtract 23 is the 86 out of 100. So you can see that this formula works out and correctly gives us this answer that we knew was right. Skip ahead to the next page and kind of go about halfway down the page until you get to this question here. Complete the formula for the union of two intersecting sets. The probability of A or B. You can do this by finding the probability of A, adding the probability of B, but then subtracting something. What needs to go on that blank? Flip back to the first page of your notes if you need to. On the blank is the probability of A and B. This statement is the addition rule for probabilities, and it's used to find the probability of one thing or another thing happening. On the next page, you see that addition rule typed out. Let's try another example and see if using that rule will help us get answers. Of the houses on Hector Street, 37% have air conditioning, 52% have a security system, and 24% have both air conditioning and a security system. Suppose a house is selected at random from the street. Probabilities are shown in the Venn diagram. So this time the diagram shows probabilities, not counts of houses. Question 8a, what is the probability a house on the street has central air? That's 0.37. The circle with the capital C is 0.37. What is the probability that the house has a security system? That's 0.52. The circle with the S is labeled 0.52. What is the probability that a house on the street has central air and a security system? This time we want the overlapped area, 0.24. Now question 9, use the addition rule to find the probability that a house has central air or it has a security system. The addition rule worked like this. The probability of C plus the probability of S minus the probability of C and S. Let's substitute our values. For this we had 0.37, for this one 0.52, and for this piece 0.24. Take a calculator and type in this math expression. The result is 0.65. There is a 65% chance that a house on Hector Street has central air conditioning or it has a security system. Move ahead to number 10. Shade the region represented by C union S, or C or S. We would want to shade everything in circle C along with everything in circle S. Number 11, if a house is selected at random on this street, what is the probability it has neither central air nor a security system? So what's the chance it's not in the shaded area? Well, do you remember the number that we had earlier figured out that was in that corner? It was 0.35. And so the probability is 0.35 or 35%. Go to the check your understanding, number 12. Write out the addition rule and use capital A and capital B to be the two events that you're working with. I'll pause the video for you to try that. Okay, here's the answer. The addition rule is the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B. Make sure that you have this symbol and this symbol correct. Question 13, using the information in the diagram, find the probability of A union B. Use the addition rule that you just wrote down. Okay, please check your answer. According to our rule, we want to take the probability of A, that's 0.47, add the probability of B, that's 0.58, and subtract the overlapped region, 0.13. Type that in your calculator and you'll have the answer. It is 0.92. Now number 14. What is the probability of the complement of the thing you just found out? I'll pause the video for you to answer that. Okay, here's the answer. To find a complement, subtract the number from 1, and you get the result 0.08. This is equivalent to figuring out that number that goes in the bottom corner of the diagram. It's everything that's not in the circles. Now go to number 15. We'll try another story problem. If a household is selected at random from Elm Street, the probability the household has lagged pipes is 0.26. Not sure what lagged pipes are, but apparently it saves energy. The probability the household recycles is 0.63. The probability that the household either has lagged pipes or recycles is 0.67. Question A, write all this information using our probability symbols. Use the letter L for the lagged pipes, the letter R for recycling. I'll give you a hint to get started. From the first sentence of the story, the probability of having lagged pipes is 0.26. We would write P of L equals 0.26. I'm going to pause the video for you to take the other sentences from the story problem and write them using our probability symbols. Here's the answer. We could write P of R equals 0.63. And the other thing that we could write is P of L union R, because of the word or, equals 0.67. That takes care of question A. Now question B. Find the probability that a randomly selected house has lagged pipes and it recycles. Remember, the word and is this symbol. Do this by filling in our numbers into the addition rule formula. What do you put in for L union R? That's 0.67. What do you fill in for P of L? That's 0.26. What about P of R? 0.63. And then it was this one that was the unknown. You could put a variable here if you like x, and then solve this equation for x. I'll pause the video for you to do that. We get x equals 0.22. So in question C, what is the value of P, L, and R? It is 0.22. This last problem illustrates that you can use the addition rule to find a union if you know numbers for these three variables, but you could also use the addition rule to find an intersection if you know the other three values. For that matter, you could use the addition rule to find this one or this one, as long as you know the other numbers. So the addition rule is not only used to find your union. You could rearrange the equation as needed to find any unknown probabilities. So let's summarize. In this lesson, we learned the addition rule, which is a way to combine probability data to figure out the probability of a union or even the probability of an intersection. These are useful in real-world situations where you're interested in more than one criteria happening.